Basically, I have two nails here that are the same diameter, and I'm going to leave one of them, this one, static, and I'm going to move the other one closer to the light source, and we're going to check what happens. And as you can see, the shadows are both really dark right now, and if I move this one closer to the light source, what happens is that the overall shadow gets larger, but the really dark bit, the umbra, is getting smaller. And that's why during a solar eclipse, the shadow cast by the moon is smaller than the moon. And in fact, if I move it even closer to the light source, what happens is that I don't really have a dark spot anymore. The shadow just becomes all blurry, really large, but all blurry. And that's why if Mercury or Venus moves in front of the sun, we don't really have an eclipse going on. It might get a tiny bit darker, but we don't have an eclipse. So let me just move it closer now. You can see it's the same nail. And now I'm going to show you just the light source for reference. And check how it looks. There you go. That's it.
These were the objects I used to create the video. As you can see, the lamp actually has 6 light sources, and this simulates the sun, since as we have seen on the previous video, we can't consider that all the light is coming from a single point in the center. It actually spreads in every direction from every point on the surface of the sun. Still, in this experiment, the dimensions of the objects and the distance between them are not to scale. It is just an example to show that when the object casting the shadow is smaller than the light source, that shadow has a dark zone called umbra, which is smaller than the object. By the way, if this was to scale, the lamp should be about 400 times larger than the nails,